Prime numbers are very useful for factoring monomials, but so many students, they forgot what's the meaning of prime numbers, or I will refresh your memory. Prime numbers are the numbers which are not divisible only by itself and 1. The rest of the numbers which are divisible by itself and 1 and by other numbers, we call it composite. But we are concentrating on prime numbers for our lesson. So what are the prime numbers? Don't take number 1 as a prime number, because number 1 is not a prime number, and if you want to ask later we can explain it. So we'll start with 2. This is a prime number. I cannot divide 2 only by itself and 1. Next comes is 3. Then comes 4, no, because it's divisible by 2, and 4 2. So 5, 6 not, 7, 8 not, 9 not, 10 not, comes 11. Next, 12 no, 13, 14 not, 15 not, 16 not, 17, 18 not, 19, 20 not, 21 not, 22, 23, and so on. That's the prime numbers to refresh your memory. Thank you. Section is about what are the factors. What sometimes so many students they hear the word factors, but they don't know what it means. Let's take an example. If you have 3 times 5 gives me 10. So what are the factors of 10? Are 2 and 5. Are there more factors? Yes, I can say 1 times 10 is also are factors of 10, which gives me 10. Well, so what is the meaning of factors? What are the two numbers multiplied together give me the number I require? So what are the factors for 12? Let's see. Let's go for 12. What are the factors of 12? Let's take 12. Factors of 12. I start with number 1. 1 times 12. Are these factors of 12? Yes, they give me 12. Now, I use here the divisibility rules. Is this number divisible by 2? Yes. So it means there is a number, I can multiply it with another number, give me 12. What is it? It's 6. See, divisibility rules, why I wanted to follow up. Now, is this number divisible by 3? Yes, yes. 2 plus 1, 3. Yes, it means there is a factor of 3 times what? Give me 12? 4. What's after 3 is 4. Once it is repeated, you stop here. So the factors of 12 are 1, 2, 3, 4, 6, and 12. 1 and 12, 2 and 6, 3 and 4. So understand what is factors of any number. Thank you. Okay. Now you know what are you know all of you what's the meaning of factors. Factors mean are two numbers multiplied together give me the number you require. But prime factors, I want the factors to be prime, so they give me the required number. We noticed that before the factors without using prime factors for 12 was, we said 1 times 12, 2 times 6, 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6 and 12. And we notice that so many factors here are not prime. So how we can use the factor to be only prime? So we use a 3, we call it 3, and I start using the prime numbers. What are the prime numbers? First number is 2. So I can divide it by 2, yes. Divided by 2 give me 6. Once it is prime, I go to the next one which is composite. Now 6, I can still go on in 2. I can divide it by 2, yes. So give me 3. Once it is stopped at 3, which is a prime number, there are more numbers. So these are the prime factors of 12. 2, 2, 2. 2, 2, sorry, 3. So look here, the factors are 1, 2, 3, 4, 6, 12, which are not all of them prime, while here all are prime. And if you multiply this together, 2 times 2, 4, 4 times 3 give you 12, which is the required number. So prime factors, let's go for 36 for example. What are the prime numbers of prime factors of 36? I start with 2 because this is even. So 2 is what? 18. After 18 is what? I go for 2 even is 9. Now 9 is not divisible by 2. I go for next one is 3. So 3 divided by 3, let's stop here because it's, the last one is a prime number. So what are the factors of 36? 2 times 2 times 3 times 3, which is equal to 36. I hope it's clear. Okay, now we use the second method of finding the GCF of 20 and 30 by using prime factorization. 20 is, I can divide it by 2, which gives me 10. I can divide it by 2, which gives me 5. Here for 30, I can start with dividing it by 2, give me 15. 15 I can divide it by 2, I go to 3, yes I can divide it by 3, so 3 is 5. Now let's see what are the common factors between the 20 and the 30. 2 and 2 is a common factor, I write 1. 2, there is no other 2. 3 and 3, no. 5 and 5, there's another one. So 2 and 5. And if you multiply them together, give you the GCF. GCF equal 10. You see, we did, the previous one gave us 10, and also the using prime factors also give us 10. Let's go to the next one. Okay, now let's go to our final step of finding the GCF of two monomials. You know, we start with the first monomial. Suppose we have 12a squared b squared c. What are the factors of 12 using prime factorization, or the classic one? So you will find that it is 2 times 2 times 3. 2 times 2 is 4, 4 times 3 is 12. This is the factors of number 12. For a square, it is a times a, 2 times. B square is b multiplied by itself twice, times c. Now, these are the factors of 12a squared b squared c. Let's do the factors of 18ab, the second term, b cubed. So the factors of 18, as you go to prime factorization or classic one, is 2 times 3 times 3, and a is alone, so there are no, we keep it as itself. B cubed is b multiplied by itself 3 times. B into b times b times b. Now let's take the common factors, or these factors of this and these factors of this monomial. So we start with 2. Here we have another 2. 2, we don't have another 2 here, we skip it. We go to 3, we have another 3. Now all the numbers done. We go to the variables. We have one variable with another variable here, a with a. B we don't have, skip it. We have b with another b here, the second b with another b here, c nothing, b is nothing. We stand with this. So from each 2 I'll take 1. So from this 2 I'll take 1. From the 3 is times 3 to a into b times b. That's all. So what is the result? 2 times 3 is 6. A, b into b is b squared, and that is the GCF of two monomials. I hope you enjoy it and understand it. Thank you very much.